All right, the next thing we're going to talk about, folks, is isomers. Isomers. And the first type of isomers we're going to look at is structural isomers. Structural isomers means you have the same molecular formula, but a different structure. Okay? So let me grab a different color here. Same molecular formula, meaning the same amount of carbons and hydrogens, right? But different structure. Okay? It's a simple enough explanation here as I go through it. So let's say this thing right here. C. This is C5H12. Just trust me on the H's. We have 12 of them. Okay, you can count them if you want. There's 3 on the first and the last, and then 2 on all the others. So this is C5H12. Look at this thing. 1, 2, 3, 4, and we have a branch off of this one. Notice that this first one here, if I call this A, this is pentane, C5H12. This one right here is 2-methyl-butane, because we got a methyl off of the 2. So still C5H12. So it is what's considered, or they are considered, structural isomers of each other. They have the same molecular formula, but there's a different structure. Obviously, you know, your pentane, you get just a long chain here, and then your 2-methyl-butane, you've got a branch off of it. That's what structural isomers are of each other. Okay? And you can figure out the structural isomers by looking at first the long chain that's got no branches, and then just start taking carbons off and putting them on branches. All right? So let me show you what I mean by that. Okay? Let's take a long chain carbon. Let's say it's C7, what would be the H? H what? 16, thanks Johnny. H16, C7, H16, because we've got times 2. Now you can't have structural isomers if you have double bonds, and that's why like the multiple bonds changes. So times 2, add 2. All right? Yeah. Of course you can, yeah. Fill out a pass and I'll sign it. So C7H16. To figure out all the structural isomers, let's go through all the structural isomers. Let's first put the long chain 7 carbon one. So 1, 2, 3, 4, 5, 6, 7. This one is just heptane, right? Now let's start getting some others. Let's make a 6-membered one. 1, 2, 3, 4, 5, 6. Can we put a branch off of the first carbon? No, because if we put it off the first carbon, it's going to be the long chain will just kind of be bent. So we can put it on the second carbon. All right? And if we put a branch on the second carbon, the name of this thing would be, well, who wants to take a shot at it? Go for it, Tense.
It would be 2-methyl.
Yep, 2-methyl. Hexane. Yeah, 2-methyl, because it's a methyl off of the 2, and then it's a hexane. So there you are. Let's do another one with a 6, and we can go 1, 2, 3, 4, 5, 6, and put it off of the 3. So this would just simply be 3-methyl hexane. Okay? Could we move, and I'll put it over here, and do another hexane? There's 6. We just had one on the 3. Could we put one on the 4th and call it 4-methylhexane? No, why not? Because we would start counting 1, 2, 3, and it would be off of the 3. Because you always want it to be off the lower branch. So basically, it's like we're looking at the back side of the 3-methylhexane. Okay, so we're done with our hexanes when we start to, if we're doing our structural isomers, we're done with our hexanes. So let's go to our pentanes. Let's put 1, 2, 3, 4, 5, and put a methyl and another methyl, right? We still have 7 carbons and 16 hydrogens, so it's a structural isomer. We would just call this 2,2-dimethyl pentane. You see how I did that? There's a pentane. Let's do another pentane. 3, 4, 5. We could put one on the 2 and one on the 3. This would be 2,3-dimethyl pentane. All right, I'm running out of room going down, so let me do another pentane. I think we can do 1, 2, 3, 4, 5. We can put one on the first, the second, and the fourth, right? 2,4-dimethyl pentane. So that's another dimethyl pentane. Could we also go, and I'm running out of room again, 1, 2, 3, 4, 5. Could we both put both carbons off of the third one? 3,3-dimethyl pentane. So I've got all my pentanes with my methyls. And Christian's absolutely right. I could go 1, 2, 3, 4, 5 and make an ethyl. Could that ethyl be off the second one? If I put my ethyl off the second one, notice that this is a long chain and really what I have is a methyl branch. Okay, so we can't have that. So we can't put the ethyl off of the second, but we sure can off of the third. So we have 3-ethyl pentane. So there's that, and that's the only ethyl pentane I can do. I can't put one off the second or the fourth. Can I do any branches with 4? Let's see if we can do that. 1, 2, 3, 4 with a long chain, and I have 3 more carbons to put. Can I go 1, 2, 3? That now gets me to C7H16, and this one would be called 2, 2, 3 trimethyl butane. Okay, and there are all my structural isomers for C7H16. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Okay, everyone understands at least what the idea of a structural isomer is. Same formula, different structures.